is an inverse function. So to understand this, we start with a very simple example, and then we'll start to understand the concept. Okay, so draw a function mapping diagram. So let's revise what that means. So you got the x value, you got the y values, and you apply the function f like we did before. So if I substitute x equal to 1, what do you get? 3 times 1 minus 2, you get 1, isn't it? I think we've seen that example before. And if you substitute 2, 3 times 2 minus 2, that will be 4. Yes, correct. 3 times 3 minus 2, what would that be? 9 minus 2 is 7. I think that's right. Okay, good. So we got the function mapping diagram. So this function maps all these x value into a y value, right? So we have this connection between the x value and the y value. Okay, that's the process. That's from the function f that changed the x value into this particular y value using the rule. So basically, a function is just a rule that changed this x value into this y value. Okay. Right, so we're now going to do the inverse function. Okay, inverse function. So what's an inverse function is denoted by this. So it's like f to the power -1 x, so we'll call that the inverse. So why is it called inverse? Just like the sine inverse we did before, we have the same symbol, isn't it, right? We have the sine inverse, inverse sine, or the inverse cos. We did that when we try to find angle, right? We do the same thing, it does the opposite. So what we do is we're going to do the inverse function that change the y value back to x value, right? So how does it work? So basically, the inverse function change, say if y is 1, so this 1 here goes back to 1, right? And then the 4 goes back to 2. So the inverse function does the opposite. And then the 7 goes back to 3. Get the idea? So that's the function inverse. And the next question you're going to ask, could we have a formula for that? So we're going to find a formula for f inverse. So it simply does the opposite. So who want to have a guess what the formula is? It does the opposite. Anyone? Inverse? Have a try? It does the opposite. So what's the formula for that inverse? Yep, someone said the answer. Who said? F inverse is? Oh, Damien, maybe you have the answer. What did you say? Said what? Yeah, but what's it equal to? Formula. So if I change y back to x, the function y. So f inverse. So what's the formula? So what calculation you have to do to the 1 to get the 1? What calculation you have to do to the 4 to get to the 2? Yeah. So you see this one, I have to multiply by 3 minus 2 before I get 1. This one I have to do times by 3 minus 2 to get 4. So what sort of operations I have to do to the x in order to find the y value? Plus 2 divided by 3. Very good. So basically, let's look at the process. We start with the x, and then we have to times by 3. We get 3x minus 2. We get 3x minus 2. That's my y value, isn't it? So this is the process by the f. And the f inverse, not only it does the inverse, you have to reverse the order of operations. So instead of times inverse, the last operation was minus 2, so you have to add 2 first. And then after you add 2, you have to divide by 3, right? So you get x plus 2 divided by 3. So we get the f inverse. Okay, right? Okay, so now we have a formula, but that's a lot of effort to get that. Maybe we can streamline this process. And the question is, how do we do that? So it's pretty easy. So all we have to do is to swap x and y and make y the subject. So we start with the function. This is the function, 3x minus 2. And all we have to do is call that y. And then we swap x and y. Swap x and y. So we write x equals to y, 3y minus 2. Right? You swap x and y and make y the subject. So you go x plus 2 is 3y. Therefore, So it does the inverse operation. Okay, and then you write therefore the inverse function equals to x plus 2 over 3. Alright, now we know how to find the inverse function, which does the opposite to the function. Okay, and this is an important part because you will have applications later on in other topics that you will learn later. Very important concept. Okay, inverse function. So, actually, I did it here. This working out should be over there. So let me drag it up. Should be here, right? Find the inverse. And get rid of that. We don't need. Oh, what to do there? Okay. So any questions? So it's pretty straightforward. Okay. Now let's draw the graph. Let's see graphically what property it has for the inverse. And it's also very interesting as well. So we now know how to find the formula for the inverse. What would the graph of the inverse look like? Okay, in relation to the original graph. So this is y equal to the function f, the original function. We're now going to draw y equal to the f inverse, the inverse function that does the opposite. And the inverse function we just calculated to be x plus 2 over 3, which is a line. And the question is, how do I draw this line? To draw this line, we have to find the x and y intercept. Let's find the y-intercept. The y-intercept will be x is 0, which is easy, y equal to 0 plus 2 on 3, which is 2/3. So mark 2/3 on the diagram, which is the y-intercept. 2/3 will be slightly below 1 over here, and label 2/3. And we also have the x-intercept. That's when y is 0. Y is 0, so for 0 equal to x plus 2 over 3, 0 equal to x plus 2, x equal to negative 2. Okay, negative 2 is the x-intercept. And then, of course, you will use a ruler. Take this letter, and then I use a ruler tool, the pen tool. Oh, no, not this one. Line, draw the line. I'm going to draw in green. Okay, let's try that. Very thick. Let's make a bit thinner. Thinner line like this. That's good size. And then elongate. Elongate. And then put arrows on both ends. Arrows on both ends. Alright, continue. So we've got this diagram. So we've got this drawing. Now, can anyone suggest what's the connection between the blue line and the green line? Any symmetry there you can observe? Yes? Yep. Yep, in between them. So that was the equation of that line. The equation of that line is x equal to y. Very good. Let's draw that. So if I draw the line y, x equal to y, you'll see that it's symmetrical around them. Where's my pen tool? That one again. So I'm going to draw it here. And what I'm going to do, because this is not the main line, I'm going to make it dotted. So let's make that dotted line. And then make that red, so you can also see it. And then, of course, arrows on both ends. Okay, cool. All right, so you have this line there that's symmetrical about. And that's true for any inverse function, not just for this particular example. Okay, so we're going to write down the equation of that line. So the equation of that line dotted is y equals to x. So it's symmetrical about this line. Symmetrical. So the f, let me write this down. So the function and the f inverse, y equal to fx and y equal to f inverse, they will be symmetrical about, actually they are a reflection of each other about this line. Oh, yes, forgot. Okay, let's write it down. So let's summarize this. The graph of this are symmetrical about the line. Do we say symmetrical, or maybe we say reflection? Reflection about the line y equal to x. Right, so reflect the green one about this line, you get the blue line, and vice versa. Okay, so we looked at inverse function. It's actually quite interesting. It's like a mirror, isn't it? Right? When you do the opposite, it's like a mirror in the middle, and they reflect about each other. What else I'm going to say? There's other thing. Hopefully you notice. If you didn't notice, hopefully you can see that there's other things that are symmetrical. Now you notice that the x-intercept and the y-intercept are the same, isn't it? See the y-intercept here, and the x-intercept are the same. And the x-intercept of the function is same as the y-intercept of the inverse. Okay, hopefully I mentioned that somewhere. But didn't I have to say that? No, I didn't. Okay, which is not surprising because we'll swap x and y. So let's write this down. The diagram gets a bit cluttered. So see this coordinate, which is 0, -2, and on the inverse, it's -2, 0. And that's because the x and y has been swapped, right? Therefore, the x and y intercept gets swapped. So we can say x and y intercepts were swapped, simply because we swap x and y in the process finding the inverse, right? Due to the swapping x and y. So any true for x is true for the y. So we got this. Yep. Okay, so it's very important because later on you're going to draw inverse graph. You're going to use this to help you to draw the inverse graph. Okay, now we have beginning to understand the inverse function. We know how to find the inverse. We know the definition of inverse, simply doing the opposite to the original function, and the graph is symmetrical about the y equal to x. Okay, but there's other things I want you to learn about the inverse, so we're going to look at curve this time. Because some of the features are not available in the straight line, are available in the curve, so we're going to draw a curve. All right, let's draw a curve. Okay. All right, so now we know how to draw inverse. So now we can draw the inverse of this function by reflecting the function about y equal to x to show its inverse. How to reflect about the line y equal to x? Now that's a little bit difficult, isn't it? So what we do is we just use this trick. You just have to swap x and y coordinates. So for example, let's say we start with this coordinate, which is 0, 1. So on the inverse, we 1, 0, isn't it? Get the idea? And you probably realize this is the exponential functions. But if not, then you can note this now. So this is 2, 0. Now this is 1, 2. So the inverse function will be 2, 1. Does that make sense? Right? So these are the points on the inverse by swapping x and y coordinates. That helps you to reflect about this line. So maybe I could get another point. So this is 2, 4. I will go to 4, 2. And eventually get a picture, isn't it? And then let's get a few more. So that's half. I think this is -1 half. So this is really the exponential function. So go half, -1. Half, -1. Yeah, I like that. Okay, so now we are ready to draw. So you will notice that we are drawing exponential, now drawing the inverse function. Okay, cool. So you notice that the asymptote, see there's a blue asymptote here, right? There's an asymptote. Now the asymptote has changed to a vertical asymptote. So a horizontal asymptote become a vertical asymptote. So things get swapped. And so basically you will realize very quickly this is y equal to 2 to the power x. And for some of you who are interested, some of you may realize if you learned that before, or maybe you've seen it somewhere, and we're going to do that as the next topic, this is log base 2 graph. Okay, you learn about log in the next topic. So that inverse function of each other. Inverse. Okay, but you don't need to know this now. I'm just telling you now, we're going to learn about log in the next topic. Okay, so when you inverse the exponential, we get the logarithm. So this is the exponential, and you learn more about that in year 12, year 11, about exponential and logarithm. A very important concept in this subject. Okay, with lots of applications. Okay, now why do we need to talk about the exponential now? Because it highlights one interesting property about the inverse. And the interesting property is that about the domain and the range. Let's write down the domain of the function. What's the domain of the blue graph? The domain will be all real x, and how about the range? No, not all real. Y is greater than 0. Very good. And if you look at the inverse, what's the domain? X is greater than 0, and the range is all real y. Can you see clearly these two get swapped? Like everything. You swap the x and y value, you swap the domain and range, you swap everything. So it's very interesting. Okay, sit down. Okay, after you do this, we're now going to find more inverse. So now we know how to find inverse just by reflecting about the line y equal to x. So this is the line. As I said that the reflection is very hard, so what you could do is to swap x and y values. Okay, so it's a reflection about this line, y equal to x. Okay, now we're going to look at, let's try to find the inverse function of a parabola. Actually, before we do that, we're going to summarize. I forgot I have a box there. You can summarize. The domain of the function becomes the range of the inverse, and the range of the function becomes the domain of the inverse. So we can work out all the features of the inverse just by looking at the original function due to the swapping of the domain and range. Okay? All right. Okay, now we're going to look at a more familiar curve that you learned before, which is the parabola. And we'll say that not all function has an inverse. Let's see why this is the case. Again, we're going to swap x and y value to help you with the process of finding the drawing the inverse by reflecting about the line y equal to x. So let me draw this line first. So y equal to x, which is here. Okay, I could extend this and then make it a bit thinner and then make a dotted line. Oh, it doesn't work, so I have to select it. Control Z. Control this, Z. Okay, so we'll do this, and then I want a red one, and then I want an arrow as well. Okay, cool. All right, good. So we see this. So it's going to be a reflection about this line. And then I could see that it works. Excellent. It's perfect. Okay, now we're going to draw the inverse. So how do you draw inverse? Maybe now you can see that if you reflect it, you can just get these points. You get a sideways parabola. Again, something you will learn next year as well, I think. Is it like that? No. Yeah. So you get a sideways parabola. Now, why does the inverse not a function? You can see quickly. Now, what's the definition of a function? You must satisfy the vertical line test. So clearly, the vertical line test does not satisfy because one x value gives you two different y values, isn't it? Which doesn't fit the domain, the definition of the inverse, the definition of function. So therefore, it fails the vertical line test. So therefore, the inverse does not exist. So not everything has inverse, right? So some has inverse, some doesn't. So that's a very important point to note. And there's an easy way to test it. Inverse function does not exist. Does not exist. So there's a quick way to tell, because now you realize that if a function fails the what we call the horizontal line test, if it crosses twice, then the function doesn't exist. So if I draw a horizontal line on a function, if it crosses twice, then the inverse does not exist. So to check if a function has an inverse, we use the horizontal line test. Now clearly with the other one, if I use the pen here because it will disappear, if I draw a line here, it satisfies the horizontal line test because it never crosses more than once, right? It satisfies the horizontal line test, but not with the parabola. It crosses twice, right? No good. Okay, so now we have a way to determine whether inverse exists and how to find the inverse. What else we're going to talk about? There seems to be a lot of theory behind it. Okay, now we'll look at the final section. Now, the parabola doesn't have an inverse, doesn't mean this is the end of the story. We can still make inverse exist by restricting the domain. So this is allowed. So it doesn't have an inverse over the whole real x, but it does have an inverse if we restrict the domain. For example, if I just selectively choose this branch of the parabola, then the inverse exists, isn't it? Because the inverse will be over here, right? That's the inverse. Because I just have to restrict in the domain x greater than 0. Then the inverse exists, because if I use the horizontal line test, it will cross us once, right? It only cross once. It will satisfy the horizontal line test. Will satisfy the horizontal line test. Okay, because we'll just ignore the negative part, right? And that's not the only way, because you can choose x bigger than 0. I could also choose the left side, right? And there's no reason not to do so, right? I could choose this bit. So I could restrict to the x less than 0. And that also has an inverse, right? So if I try to draw the inverse, it will be over here, right? That's the inverse. Okay, because again, it will satisfy the horizontal line test. Because if I draw this, it only crosses once, right? Crosses once. But does that mean there's only two ways to do that? Well, not really, because it doesn't have to be left or right. You could just do this. I could just choose this section here. That has an inverse. Because it doesn't have to, so I could restrict in the domain between, let's say, x between 1 and 2. So in that way, we have an infinite possibility of finding the inverse. So I could restrict to here, so the inverse will be, let me have a try, will be over here, right? That's the inverse. That's the inverse. So there's more than one way, and of course the question will tell you which way to restrict. So the question will be very clear how to restrict the domain. So you don't have to worry about which one to choose. Like that. Okay, get the idea? So let me just show you the whole page so you can all see. I went through a little bit quick. Okay, so there's more than one way to restrict the domain. Okay, you can restrict x greater than 0, x less than 0, or you even just choose x between 1 and 2, and many, many more, many more. Okay, let's look at an example. I think that's the last example we'll do before we do the exercise, and then we'll do a summary on the next lesson. Okay, let's look at this quadratic function, parabola. As we know, it does have an inverse. Write down the largest set of x, the domain that include the point A, which an inverse exists. Okay? Well, you have to include this point, and you want to be the largest domain, the largest. So how do we restrict the domain? So obviously, you have to choose this bit, right? When you choose this bit, you will satisfy the horizontal line test, right? It doesn't cross more than once. And what bit would that be? X has to be less than or equal to -2. Write down the largest x value for which, yeah, so that inverse will exist. And that also, so inverse exists, right? And also include point A. So it's unique, and it is the largest domain. So it's unique. All right, so hopefully you're clear about the inverse, how to find inverse, how to draw an inverse, how to restrict the domain of a function so that inverse exists. That's what we did today. So very important concept. You'll learn later in year 12 and 11. Yes? Maybe in the exercise you do, let's have a try. So use the trick again, swap x and y values. So -2, 3. So I go -2. So this is -2, 3. So the inverse will be 3, -2. Right? Let's do more. What's the next point? This is -4, 0. I think we got it. So if you get more points, eventually you get this graph. Yeah, it's quite interesting. Right? So that's the inverse. And this is 3, -2. So swap x and y values. That's the easiest way to draw inverse. And you will see that again, it will be reflection about the line y equal to x. Right? All good. Any question? I think you're ready. Start the exercise now, the last exercise. Okay, start now. Thank you.